Today's objective is transformations, particularly translations. A transformation is a change made to the location or size of a figure. So there are several different types of transformations. A translation is a change to the location of a figure. The new moved figure is called an image. And that's like when you look in a mirror, what you see is your image. You're not seeing another person over there, unless it's a movie or something, right? Okay, so here I have a triangle ABC, and it's located at these 3 points. That's where the vertices are: -1, 1, -6, 1, and -1, 5. I have moved it, okay? I've made another one, and its points are A prime, B prime, C prime. Looks like a little apostrophe, but we call it prime. And its points are -2, -3, 3, 1, and 3, -3. To describe the translation, you write how you moved the X and Y coordinates. You can also write it in words, just describing it. So let's read the words first. In words, you could say, move 4 units right and 4 units down. So if I take point A, I could move 4 units to the right. So if it's at -6, if I move 4 units, I should be at -2, and then move 4 units down. If I'm at 1 and move down 4, I get to -3. You could do the math with it. -6 plus 4 is -2. 1 minus 4 is -3. Let's do the same with point B. Here I am at -1, 5. If I move 4 to the right and 4 down, -1 plus 4 is 3. 5 minus 4 is 1. And that's where my B prime is. The new points are written as A with the little apostrophe and are called A prime, B prime, and C prime. Okay, and that's how you can tell which is the new image and which is the regular figure and which is the new image. And if we're talking about it mathematically, algebraically, we would say if you take your each X and Y coordinate and add 4 to the X, and actually this isn't supposed to be like that, sorry. Add 4 to the X and subtract 4 from the Y. Sorry, I'm getting carried away. Let's do another one. Here I have a rectangle. Here are its points A, B, C, D. The points are -1, 1, -5, 1, -5, 2, -1, 2. And here's my new rectangle, my new image. A prime, B prime, C prime, D prime. Can you see what we did? Let's see what we did. Here I'm at, let's look at point A to A prime. Here I'm at -1 for my X value, and here my X value is 6. What's the difference between those? Hopefully you said 7. And here I'm at 2, up 2, and here I'm at 5. What's the difference between those? 3. So I could say move 7 units right and 3 units up. Want to check it with another one? -5 plus 7 should be 2, and -1 plus, how many did I say? 3? -1 plus 3, 2. So these are the words: move 7 units right and 3 units up, and this is the math. Take your X and Y, add 7 to your X and 3 to your Y. Subtracting is going down or to the left, adding is going up or to the right. Okay, one little other thing. Tessellations. A tessellation is a plane covered by a shape or shapes with no overlaps or gaps. Some figures can tessellate, some cannot. So here I took some triangles and I drew them, and you can see that I can cover the plane. Plane's like a piece of paper, right? You can cover the plane without any overlaps or any gaps. So some of these have been turned. You could say I turned it, which is called rotated, or flipped over, which is called reflected. Here's another polygon, but this is not a tessellation by itself, because even though I don't have overlaps, I do have gaps, even though, and it's beautiful drawing, isn't it? So, but there are gaps. But if I drew them all symmetrically, I think I could put other shapes in to make a tessellation. I think I could probably put in some like pentagons up here and maybe hexagons up here, or maybe more pentagons, right? I think I could do that. So this shape does not tessellate by itself, but this does. Can a rectangle tessellate? Hope You said yes.